Let's talk about light waves and electrons. And right now, we're still trying to describe the mathematical relationship between energy, frequency, and wavelength of light using the electromagnetic spectrum. And this video, we're going to really focus on using the electromagnetic spectrum. So the electromagnetic spectrum is a range of all the frequency and wavelengths of all the different types of light waves. And it goes from very long, low energy radio waves to very, very short, high energy gamma rays. And all these different types of electromagnetic radiation or different types of light waves have allowed modern life to be what it is. Radio waves allow us to listen to music and to communicate. Microwaves to use our cell phones and cook our food. Visible light is all the light that we can see in all the different colors: red, orange, yellow, green, blue, violet. And red has the longest waves, violet has the shortest waves. Ultraviolet light, which allows us to kill bacteria and viruses by damaging their DNA. But it's also why we have to worry about UV light from the sun so that it doesn't damage our DNA and our skin cells. So we wear sunblock. X-rays to look inside of our bodies. The electromagnetic radiation that is here makes up all the different types of waves, and they're all produced by different types of charged particle motion. Now, when I look at an electromagnetic spectrum, I want to identify how the waves are changing on that particular spectrum. Here, I can see that the wave are getting closer and closer to each other. There's a shorter distance between the waves as I move to the right. So this has a decreasing wavelength moving to the right. Now, wavelength and frequency are opposites. So if the wavelength is decreasing going to the right, then it is increasing in frequency going to the right. The waves are becoming more and more close together, so there are more and more waves. This is an increasing frequency. And we know that frequency and energy are synonymous, that they move in the same direction. So we can also say it's increasing energy going to the right. Now, being able to use the electromagnetic spectrum is useful for being able to compare different types of energy and different types of motions of charged particles. And what I want you to be able to do is take any electromagnetic spectrum and generate an understanding. So here's a different one, and I want to walk you through the steps of what I hope you can do. Number one, this one's different because there are no waves on it. So if there are no waves, then I really got to look for these labels that tell me which way the frequency and the wavelength are changing. Now, I always like to go ahead and write energy in as well if it's not. So I'm going to put energy with increasing frequency because we know that energy and frequency go together. And then the last thing I like to do is actually draw my waves. So here it's increasing wavelength to the right. So the waves are longer on the right. And so I'm just going to draw on my chart some squiggles that are getting longer to the right. And for this, you must use the labels. Now, I can compare different wavelengths, different energies, different frequencies, and I can tell you about two different types of radiation when compared to each other.